With this lecture on hypothesis testing, we begin our discussion how we can actually utilize data to explore causal relationships. So this lecture will lay out the foundations of statistical hypothesis testing, which is a way of testing whether the correlations we see in data are simply due to chance. And the lecture will lay out some of the key terms involved in hypothesis testing, which sets up the rest of this section. So first, what is statistical hypothesis testing? This is how we know whether the correlation between X and Y that we observe in a sample isn't simply due to chance. So is there really a relationship between X and Y in the population? It's not actually testing for causality, despite using the confusing term hypothesis testing. We're just looking to see if there is some sort of correlation, some sort of relationship between X and Y. And the key is that we're looking to see that the relationship is strong enough that we can conclude that it isn't simply just a fluke that we saw some sort of small relationship there. That is something that really we can determine is there for some systematic reason. So let's talk about what this looks like with an example. So imagine that you're doing a clinical flu vaccine trial. So this is a pharmaceutical company and they are developing a new type of flu vaccine. So they run a trial that has 50 people in the treatment group and 50 people in the control group. So the people in the treatment group received the vaccine, the people in the control group, they received some sort of placebo. All right. So the question is whether this is effective. We find that 20% of people in the treatment group got flu in the past year versus 22% of people in the control group, right? So it is definitely some sort of relationship. We can see here that people who are in the treatment group were less likely to get the flu last year. But can we really conclude that isn't just some sort of fluke? Do we know if the vaccine was actually effective? Or was that just really due to some sort of natural variation that we'd see in the population? So to do this, we use a hypothesis test. So let's talk about the elements that are involved in a hypothesis test. First, there's the null hypothesis. And the null hypothesis is a general statement that there is no relationship between X and Y. This is what we always start from. This is our starting point. So even if you see a relationship in the data, we can't conclude that that the relationship in the data isn't simply due to chance. So with the null hypothesis for our flu vaccine example is that there's no relationship between those who receive the vaccine and getting the flu. That the flu vaccine, those receiving flu vaccine are just as likely to get the flu as those who didn't receive the vaccine. All right. In other words, X has no effect on Y. In contrast, the alternative hypothesis, which we denote as HA, is a statement that's contradictory to the null hypothesis, that there is some sort of relationship between X, Y. And so here, the alternative hypothesis is that those receiving the flu vaccine are less likely to get the flu than those who don't receive the vaccine. Okay, so what we're going to be doing here is we're going to be testing our null hypothesis and figuring out if we can dismiss it. So we always test for HO for the null hypothesis. We never test directly the alternative hypothesis. And so we want to see if we have some sort of reasonable level that we can conclude that the null hypothesis of no relationship is extremely unlikely. But the key here that I want to just really emphasize is that rejecting a null hypothesis is not the same as establishing a causal relationship. So remember Kelstedt and Witten's 4 hurdles of causality. Just because you're rejecting the null hypothesis, that means that you're able to say that there's some sort of correlation. But that's only one of the hurdles. So you could, say, have reverse causality, or you could have some other factor that is causing the outcome, or it could just be a fluke. You need to identify the causal mechanism that's involved here, and you need to explore other ways to really test your hypothesis. And another point to really emphasize is that we can never actually approve either hypothesis. So this should make sense to you, just thinking through it intuitively. We are testing the null hypothesis, And what we're really trying to do is assess the likelihood that the null hypothesis is discredited and that the results that we find are due to chance. But there is a possibility that it is due to chance. We're never going to get to 100% confidence. So think back to those normal curves we talked about in the confidence interval lecture. There you saw that you could have a really, really extreme value that was extremely unlikely, but was feasible, right? And so there's always this possibility that we see a relationship that's just due to fluke. It could be really unlikely, but we can conclude that we are rejecting the null hypothesis. We won't ever get to 100% confidence, but we can get to a pretty high level of confidence. And that's what we're going to talk about in the next lecture.